Welcome. Today we're going to talk about solving multi-step equations with a technique called clearing decimals. Our algebra teachers call this technique decimal busters. It is considered one of the power tools for solving equations. Before we begin, let's just review how you multiply decimal numbers by powers of 10. For every 0, we move the decimal one place to the right. So multiplying 4.15 by 10 moves that decimal one place to the right. The answer would be 41.5. To multiply 73.1 by 100, we would want to move the decimal two places to the right, and I call this putting an egg in the carton. The answer would be 7,310. So, on to solving equations. This example is negative 2.5r plus 4.5 equals negative 10.5. Let's look how many decimal places there are in each term. In negative 2.5r, there's one decimal place. In 4.5, there's one decimal place. And in negative 10.5, there's one decimal place. So they all have one decimal place. We want to move the decimal one place to the right to clear the fractions, and that's achieved by multiplying both sides of the equation by 10. By using our distributive property, we're allowed to multiply all the terms by 10, and let's go ahead and move all those decimals one place to the right. That's going to give us the equation negative 25r plus 45 equals negative 105. I probably wouldn't even bother writing the decimal point at the end of each of those numbers at this point, because now they're just integers. And we're going to solve it the way we solve all two-step equations. Step 1, add or subtract. And let's go ahead and subtract 45 on both sides. So 45 minus 45 is 0, so we end up with negative 2.5r, or negative 25r, equals negative 150. And step 2, multiply or divide. In this case, we're going to divide both sides by negative 25, because a negative divided by a negative is a positive. So that gives us positive 1r equals 6. Problem solved. Box it out. Let's move on to example 2. Okay, in this example, 1.2n, the 1.2 has one decimal place, plus 3.4, one decimal place, equals 10. There are no decimal places, so we don't have the same amount of decimals on everything. We have to move the decimal enough times to clear the longest decimal, which is one place, which means on the 10, we're going to have to add a decimal point and then move it. So we're going to multiply this whole thing by 10 and move each decimal one place to the right. That means we're going to want to put an egg in the carton. So we get 12n plus 34 equals 100. Now it's a simple two-step equation. I usually box the term with the variable. First I solve for the box, then I solve for the variable. Okay, so subtract 34 on each side. 34 minus 34 is nothing. So we get 12n on the left-hand side and 66 on the right-hand side. The final step, divide both sides by 12. 12 divided by 12 equals 1, or just n. Now I know that 12 times 5 equals 60, so that's going to leave 6/12, or a half. We'll call it 5.5. Problem solved. Final example. Again, feel free to pause the video and work the example on your own if you can. If not, you can follow along with me. We're going to do 2.25x, which has two decimal places, minus 0.15, again, two decimal places, equals 6.6, one decimal place. So how many times do we need to move the decimal? And we need to move it twice, which means we're going to multiply by 100 the entire equation technically we're multiplying by 100 on the left side and we're multiplying by 100 on the right. This is a sort of a shorthand way of showing that. Anyway, multiplying by 100 is going to move that decimal twice. Once, twice, and again on the 6.6 there is a gap and we're going to drop a 0 in there. So we end up with 225x minus 15 equals 660. This time we box the 225x. We're going to add 15 to both sides of the equation, and we get 225x equals 675. Last step, we want to divide both sides by 225, which conveniently goes into 675 3 times. The answer, x equals 3. And that wraps that up. Okay, good luck.